Look up at the southern sky. The third brightest star in the heavens is Alpha Centauri. To the naked eye, it looks like a single lonely point of light. But our eyes deceive us. If you traveled there, you wouldn't find a single sun. You would find a complex celestial dance of three stars. And orbiting the smallest, faintest member of that trio is something that has kept astronomers awake at night. A world that looks suspiciously like Earth. Today, we're leaving the solar system. We aren't going to the edge of the universe. We're going to our own backyard to visit the neighbors. But be warned, just because they are close doesn't mean they are welcoming. This system is a place of scorching radiation, eternal twilights, and physics that defy our daily experience. So, is Alpha Centauri our future home or a cosmic trap? Let's find out. To understand our destination, we must first understand the geography of the Alpha Centauri system. It is located just 4.37 light-years away. In cosmic terms, that is right across the street. The system is dominated by two massive stars, Alpha Centauri A and Alpha Centauri B. Alpha Centauri A is the patriarch. It is a G-type yellow dwarf, almost identical to our own sun, just slightly larger and roughly 1.5 times brighter. However, a crucial detail excites astrobiologists. Alpha Centauri A is metal-rich. In astronomy, metals are anything heavier than hydrogen and helium. This star contains significantly more heavy elements, like iron and carbon, than our own sun. This matters because planets are built from these heavy elements. A star rich in metals implies it had plenty of building blocks available at birth, significantly increasing the odds of rocky planets forming there. Its partner, Alpha Centauri B, is slightly smaller, a K-type orange dwarf. It glows with a cooler, softer orange light, emitting only about half the energy of the sun. These two are locked in a gravitational embrace, but their dance is chaotic. They orbit each other once every 80 years in a highly stretched ellipse. At their closest approach, they're roughly the distance from Saturn to the Sun, but at their farthest, they drift apart to the distance of Pluto. This extreme variance creates a gravitational tug-of-war. The constantly changing gravity fields would likely destabilize any planet trying to orbit too far away from its parent star. If Earth were in this system, orbiting far out, it might be flung into deep space by the passing sibling. However, computer models show that planets can exist if they hug their stars tightly, staying in the stable zone. For decades, we searched for worlds around these two golden stars. Despite rumors and false alarms, Alpha Centauri A and B remain eerily silent. We haven't confirmed any planets around the big brothers yet. But these two wealthy stars have a distant, poorer sibling, and that's where the real action is. About a fifth of a light-year away from the central pair, so far that it takes light 70 days to travel between them, orbits the third member, Proxima Centauri. Proxima is a red dwarf. It's small, only about 12% of the mass of our sun, and just 1.5 times the size of Jupiter. It's so dim that even though it's the closest star to Earth, it's invisible to the naked eye. For decades, astronomers thought Proxima was just a boring bystander. But in 2016, the data shifted. We found that this tiny dim star is hiding secrets that could change the future of humanity. Proxima Centauri might be small, but do not let its size fool you. It's violent. To understand why, we have to look inside. Unlike our sun, which has a complex internal structure that dampens its outbursts, Proxima Centauri is fully convective. The plasma inside the star circulates from the core to the surface in one continuous loop. This constant churning generates incredibly powerful and unstable magnetic fields. When these magnetic field lines twist and snap, they release energy that dwarfs our sun's solar flares relative to the star's size. In 2019, astronomers detected a terrifying flare. In seconds, the star became 14,000 times brighter in the ultraviolet spectrum. If you were standing on a nearby planet without protection, that flare would have been a lethal dose of radiation, capable of stripping away the ozone layer in an instant. This presents a paradox. Red dwarfs like Proxima are the most common stars in the galaxy and live the longest. They should be the best places to look for life because of their longevity. But they're also the most temperamental. This brings us to the habitable zone. Because Proxima is cold, about 3,000 degrees Kelvin, its habitable zone is dangerously close. To be warm enough for liquid water, a planet must orbit at just 5% of the distance between the Earth and the Sun. At that distance, the planet is sitting in the barrel of a gun, constantly blasted by solar wind. But let's assume life found a way. What would it look like? The light from Proxima is not white-yellow, it's deep red and infrared. On Earth, plants are green because they use high-energy blue and red light. But on a world around Proxima, there is little blue light. Astrobiologists theorize that to survive, plant life would evolve to absorb as much light as possible. They wouldn't be green, they would likely be black, dark purple, or dark red, hungry for every photon. Imagine a landscape of black forests under a salmon pink sky, constantly braced for the next ultraviolet storm. There's another consequence of being so close: tidal locking. Gravity acts like a brake. Because the planet is so close, Proxima's gravity likely slowed its spin until it matched its orbit. One side faces the star forever, baked in eternal day. The other side faces the black, freezing void, locked in eternal night. Life there would have to exist on the edge, literally. Now, before we look at the planets, we must address the elephant in the room. We're talking about a triple star system. Science fiction, most notably the three-body problem, has taught us that such systems are chaotic, hellish environments where planets are ripped apart by unpredictable gravity. You might be thinking, how can a planet survive here? The answer lies in distance. Alpha Centauri is not a chaotic system, it's a hierarchical one. Proxima Centauri is massive distances away from the central pair, about 13,000 astronomical units. To a planet orbiting Proxima, the two larger stars, A and B, would not look like suns. They would essentially be two extremely bright stars in the night sky. Because Proxima hugs its parent star so tightly, orbiting 20 times closer than the Earth orbits the Sun, it's locked deep within Proxima's gravitational grip. The pull from the distant twin stars is negligible. So dynamically, the planet is safe. It won't be flung into space. But being safe from gravity doesn't mean it's safe for life. Meet Proxima Centauri B. Discovered in 2016, this world is roughly 1.17 times the mass of Earth. Because of the tidal locking, Proxima B is likely an eyeball planet. The center of the day side acts like the pupil, a scorching desert where the sun hangs motionless. The night side is the white of the eye, a frozen wasteland of ice. But in the middle, along the terminator line, the twilight zone where the sun never fully rises or sets, the temperatures might just be right. Models suggest if Proxima B has an atmosphere, heat could circulate. Strong winds would blow from the hot side to the cold side, creating a permanent storm system. This twilight strip could be a lush, habitable band of eternal sunset. But if is the dangerous word here. Does it have an atmosphere? The intense solar flares might have stripped the atmosphere away billions of years ago. However, if the planet formed with a thick hydrogen layer or has a super strong magnetic field, it might have survived. The James Webb Space Telescope is currently trying to analyze the heat signature of the planet to tell us if there is air to breathe. And Proxima B isn't alone. In 2020, we found evidence of Proxima C. This is a very different beast. It orbits far out, past the snow line, taking over 5 years to complete a circle. It's a super-Earth, or mini-Neptune, roughly 7 times the mass of Earth. Direct imaging suggests it might be surrounded by a massive ring system, a frozen giant watching from the dark. Then, in 2022, the Espresso instrument confirmed a third sibling, Proxima D. One of the lightest exoplanets ever found, it completes a full year in just 5 days. It's likely a ball of molten rock, sterilized by the red eye of Proxima. So, we have a complete system, a hot rock, a frozen giant, and in the middle, a potential second Earth. Alpha Centauri is more than just a point of light. It's a destination. We have found the stage. We have found the scenery. We know the physics of the star and the layout of the planets. The only thing missing is the ability to walk on the surface.